Hello and welcome to our first coding session. In this video, we will familiarize with the IPython notebook environment and we will run a first deep learning model. Don't worry if you don't understand everything in the code, because this is just to whet your appetite, and we will have plenty of occasions in the course to actually understand what we're doing. The Jupyter Notebook is an interactive environment that allows us to execute Python code in cells. This, for example, is a cell, but this too is a cell. This is a markdown cell that we can use to add text to comment our work. If I double click on a cell, the cell becomes active and I can edit it. For example, I can change this and say author. For example, I can change this and add a word. Hello, this is our first model. To execute the cell, I can either hit cell run, which will run it, or more simply, I can hit shift return. This will also run the cell. Running a markdown cell just renders it in markdown. Running a cell that contains code executes the code contained in the cell. If I run a cell with an error, the error will be shown. If you're new to Python, it's important that you understand how to read error messages. The most important part of an error message is the last part. Here it's saying syntax error, invalid syntax, and then it indicates where the problem is. In this case, since there's only a line, it's very simple to correct the error. But keep in mind that when there is a long error message, always look for the last message, for the last line first. That contains the clue of solving the problem. Okay, so the first line here imports NumPy, which is the library that contains all the linear algebra functions like vectors, matrices, and so on. It's always good to import it when you're doing data work. Then in this cell, we import matplotlib and use a cell magic. A cell magic is a very special IPython construct that allows us to add functionality to the IPython notebook environment. In this particular case, we are setting the inline instruction to the matplotlib plotter. What this means is that when we generate a plot using matplotlib, it will be displayed in the notebook itself. Then we import a generator of samples from a library called scikit-learn. Scikit-learn is Python's primary machine learning library, and it comes with a lot of utilities, like, for example, a data samples generator. We import the make circles, and you will understand immediately what this does. In the next cell, we call the make circles functions with some parameters. Let's look at them. We have the number of samples, we say 1000, a certain level of noise, a factor of 0.2, and we'll see what that means, and we also set the random state. Don't worry about this. What's important is that this function has two outputs. We assign them to the variables x and y. So let's look at x first. X is a matrix, so it has rows and columns, and if we look at the shape, it has 1000 rows and 2 columns. This corresponds to the number of samples, and we have 2 features for each sample. Let's plot the values of x, and let's plot them in 2 different colors, in blue for the points of x that correspond to y equals to 0, and in red with a cross for the points that corresponds to the label of y equals to 1. This is our training data. We have data on the outer circle that belongs to a certain class, and data in the inner space here, the crosses, that belongs to the other class. In machine learning, we often want to train models to separate two classes. In this case, a model should learn that there is kind of a circular boundary between the red crosses and the blue dots. Now, let's go ahead and build our first deep learning model. I will not explain what each of these lines does, because we will go through these for the rest of the course. Let's just see how simple it is to define a deep learning model. It's literally these 3 lines where we import the relevant classes from Keras. Keras is the library we will use for the whole course for doing deep learning. And then 1, 2, 3, 4 lines to define the model, and a 5th line to fit the model. Now, what's important is when you execute the line that fits the model on the training data, x and y, you can define a number of epochs, and we will learn what these are in the course. Now, focus your attention on the output here. The output here tells us a certain number loss, which seems to be decreasing over time, and another number called AC, which stands for accuracy, which seems to be increasing over time. Again, we will have the whole course to learn about these numbers and what they mean, but keep in mind this: we are running a fitting procedure over a thing called epoch. So first epoch, second epoch, third epoch, etc. And a number called loss is decreasing while a number called accuracy is increasing. Now, what we do in the rest of the notebook is just to draw the decision boundary of our model. To do this, we define a grid of points using a function from NumPy called linspace. Linspace generates a sequence of numbers, exactly in this case 101 numbers, between the minimum value of -1.5 and the maximum value of 1.5. We call these horizontal ticks. And then we have vertical ticks, which have the same grid spacing. Then we do a bit of manipulation here to generate a grid of points that we end up calling AB. So AB is a grid of points that both in x and y have coordinates between -1.5 and 1.5. Then we predict with our model the values of the grid, and we reshape the prediction to have the same shape as the grid. Don't worry if you don't understand these lines. It's just boilerplate in order to generate the next figure. In the next figure, we plot the same data and we overlay a contour function, a contour plot of our prediction grid. As you can see, our model has learned a profile that separates really well the internal red crosses from the outer blue dots. I hope this served to whet your appetite. Maybe you've not understood everything, but I hope I've convinced you that building a deep learning model with Keras is actually very, very simple. Before I go, I want to teach you a little trick of IPython Notebook. If you are on a cell, you can see that the cell is surrounded by a green rectangle. If you hit the button Escape, the rectangle becomes blue, light blue. This means we are in notebook mode. And in notebook mode, we can access some keyboard shortcuts to facilitate our navigation of the notebook environment. The most important shortcut is the letter H. If I press H in notebook mode, it will display all the keyboard shortcuts in a help. So look how many keyboard shortcuts there are. I strongly encourage you to have a look at these keyboard shortcuts, in particular how to run a cell. We've already seen that is Shift Return, but also how to add cells and how to delete cells. This will make you very proficient in the use of IPython Notebook. Thank you for watching and see you in the next video.